A full-frame digital SLR is a digital single-lens reflex camera fitted with an image sensor that is the same size as a 35mm film frame. This is in contrast to cameras with smaller sensors, much smaller than a full 35mm frame. Currently, the majority of digital cameras, both compact and SLR models, use a smaller than 35mm frame, as it is easier and cheaper to manufacture imaging sensors at a smaller size. Historically, the earliest digital SLR models, such as the Nikon NASA F4 or Kodak DCS 100, also used a smaller sensor. Kodak states that 35mm film has the equivalent of 6K resolution according to a senior vice president of IMAX. Use of 35mm film camera lenses. If the lens mounts are compatible, many lenses, including manual focus models, designed for 35mm cameras can be mounted on DSLR cameras. When a lens designed for a full-frame camera, whether film or digital, is mounted on a DSLR with a smaller sensor size, only the center of the lens's image circle is captured. The edges are cropped off, which is equivalent to zooming in on the center section of the imaging area. The ratio of the size of the full-frame 35mm format to the size of the smaller format is known as the crop factor, or focal length multiplier, and is typically in the range 1.3:2.0 for non-full-frame digital SLRs. Advantages and disadvantages of full-frame digital SLRs. 35mm lenses. When used with lenses designed for full-frame film or digital cameras, full-frame DSLRs offer a number of advantages compared to their smaller sensor counterparts. One advantage is that wide-angle lenses designed for full-frame 35mm retain that same wide angle of view. On smaller sensor DSLRs, wide-angle lenses have smaller angles of view equivalent to those of longer focal length lenses on 35mm film cameras. For example, a 24mm lens on a camera with a crop factor of 1.5 has a 62° diagonal angle of view, the same as that of a 36mm lens on a 35mm film camera. On a full-frame digital camera, the 24mm lens has the same 84° angle of view as it would on a 35mm film camera. If the same lens is used on both full-frame and cropped formats, and the subject distance is adjusted to have the same field of view in each format, depth of field is in inverse proportion to the format sizes, so for the same f number, the full-frame format will have less DoF. Equivalently, for the same DoF, the full-frame format will require a larger f number. This relationship is approximate and holds for moderate subject distances, breaking down as the distance with the smaller format approaches the hyperfocal distance, and as the magnification with the larger format approaches the macro range. There are optical quality implications as well, not only because the image from the lens is effectively cropped, but because many lens designs are now optimized for sensors smaller than 36mm or 24mm. The rear element of any SLR lens must have clearance for the camera's reflex mirror to move up when the shutter is released. With a wide-angle lens, this requires a retrofocus design, which is generally of inferior optical quality. Because a cropped format sensor can have a smaller mirror, less clearance is needed, and some lenses, such as the EFS lenses for the Canon APS-C-size bodies, are designed with a shorter back focus distance. However, they cannot be used on bodies with larger sensors. The full-frame sensor can also be useful with wide-angle perspective control or tilt-shift lenses. In particular, the wider angle of view is often more suitable for architectural photography. While full-frame DSLRs offer advantages for wide-angle photography, smaller sensor DSLRs offer some advantages for telephoto photography because the smaller angle of view of small sensor DSLRs enhances the telephoto effect of the lenses. For example, a 200mm lens on a camera with a crop factor of 1.5 has the same angle of view as a 300mm lens on a full-frame camera. The extra reach, for a given number of pixels, can be helpful in specific areas of photography such as wildlife or sports. Lower size sensors also allow for the use of a wider range of lenses, since some types of optical impurities are most visible around the edge of the lens. By only using the center of the lens, these impurities are not noticed. In practice, this allows for the use of lower-cost glass without corresponding loss of quality. Finally, full-frame sensors allow for sensor designs that result in lower noise levels at high ISO and a greater dynamic range in captured images. Pixel density is lower on full-frame sensors. This means the pixels can be either spaced further apart from each other, or each photodiode can be manufactured at a slightly larger size. Larger pixel sizes can capture more light, which has the advantage of allowing more light to be captured before oversaturation of the photodiode. Additionally, less noise is generated by adjacent pixels and their EM fields with larger photodiodes or greater spacing between photodiodes. For a given number of pixels, the larger sensor allows for larger pixels or photosites that provide wider dynamic range and lower noise at high ISO levels. As a consequence, full-frame DSLRs may produce better quality images in certain high-contrast or low-light situations. Production costs for a full-frame sensor can exceed 20 times the costs for an APS-C sensor. Only 20 full-frame sensors will fit on an 8-inch silicon wafer, and yield is comparatively low because the sensor's large area makes it very vulnerable to contaminants. 20 evenly distributed defects could theoretically ruin an entire wafer. Additionally, when full-frame sensors were first produced, they required 3 separate exposures during the photolithography stage, tripling the number of masks and exposure processes. Modern photolithography equipment now allows single-pass exposures for full-frame sensors, but other size-related production constraints remain much the same. Some full-frame DSLRs intended mainly for professional use include more features than typical consumer-grade DSLRs, so some of their larger dimensions and increased mass result from more rugged construction and additional features as opposed to this being an inherent consequence of the full-frame sensor. Other uses of full-frame, CCD image sensor architecture. The term full-frame is also used to refer to a type of charge-coupled device sensor technology in which the sensor elements occupy the entire sensor surface rather than sharing space with associated pixel storage sites. The use of full-frame CCDs is typically restricted to digital SLRs since they require the use of a mechanical shutter and do not output a continuous image. The two uses of the term full-frame are not otherwise related. 135 film cameras. In 35mm cameras, the terms full-frame and half-frame were used to distinguish the 24AA, A36mm and 18AA, A24mm film formats. The half-frame 35mm film format is also known as single-frame in movie film, and as a result, full-frame film cameras were sometimes known as double-frame. Past and present full-frame digital cameras, DSLRs. Contax and digital, Canon EOS 1DS, Kodak DCS Pro 14N, Kodak DCS Pro SLRN, Kodak DCS Pro SLR-C, Canon EOS 1DS Mark II, Canon EOS 5D, Nikon D3, Canon EOS 1DS Mark III, Nikon D700, Sony I+± DSLR A900, Canon EOS 5D Mark II, Nikon D3X, Sony I+± DSLR A850, Nikon D3S, Canon EOS 1DX, Nikon D4, Nikon D800/Nikon D800E, Canon EOS 5D. Mark III, Sony I+± SLTA99/Sony I+± SLTA99V, Nikon D600, Canon EOS 6D, Nikon D610, Nikon DF, Nikon D4S, Nikon D810, Nikon D750, the Nikon E2/E2S, E2 and E2NS and E3/E3S digital SLRs as well as the similar Fujifilm Fujix DS505/DS515, DS505A, DS515A and DS560/ DS565 models used a reduction optical system to compress a full-frame 35mm field onto a smaller 2/3-inch CCD imager. They were therefore not digital SLRs with full-frame sensors, however had an angle of view equivalent to full-frame digital SLRs for a given lens. They had no crop factor with respect to angle of view. Nikon has designated its full-frame cameras as FX format and its smaller sensor cameras as the DX format. Rangefinders, Leica M9, Leica M9P, Leica M Monochrome, Leica ME, Leica M. Other technologies, Sony Handycam NEX-VG900, a 35mm full-frame video camera with interchangeable lenses, Sony Cybershot DSLR-X1 and Sony Cybershot DSLR-X1RA Euro full-frame compact cameras with fixed lens, Sony I+/ILCE7 and Sony I+/ILCE7 as well as Sony I+/ILCE7SA Euro full-frame mirrorless interchangeable lens cameras, features of full-frame DSLR, prototype, full-frame digital SLRs, Pentax MZ-D Mr. 52, Sony Alpha flagship model CX62500, though with many detailed differences, see also, image sensor format, references.